Okay, so tonight's second lesson on polynomials. The entire first lesson was all about expanding brackets, so multiplying brackets by brackets, or multiplying single things by brackets, or multiplying uh, brackets with 2 or 3 terms by other brackets with 2 or 3 terms. And now we're going to start into the second half of chapter 6, which is all about trying to reverse that process, which is a little trickier, but not too bad. So there we go. So just as a quick review, let's expand a couple brackets, and then we're going to do this repeatedly in this lesson. We're going to start with the bracket expanding we already learned, and then we're going to look at what we get and try and figure out a pattern that would help us turn that question around and do it in reverse. So give you a quick second to practice some of the stuff we did in our first lesson here. Okay, so we're going to take the 5 and we're going to multiply it into the bracket. So 5 times x is 5x. There's a plus sign in front of that. Doesn't look like we need it in this case, but always think about that every time you expand. And a 5 times positive 7 is plus 35. Well, that plus we do need, right? Because if we didn't put it there, it would just say 5x 35, which is not what it is. So both those terms are positive. We don't need to write the plus in front of the first one in this case. And then down here, c times c squared is c cubed. That's c to the 1 times c to the 2. You add the exponents, get c to the 3. And c times negative 5 is negative 5c. Okay, there's some nice simple brackets that we expanded. Now, what we want to try to do now is we want to try to reverse that process. And we're going to learn four main types of factoring. 3 of them we're going to do right now, and then the fourth one takes a little more time. We're going to do that in our next class. So factoring is the opposite of expanding. We're trying to get back to the bracketed form. So when you are factoring, you will be given something like your answer here, 5x plus 35, and be asked to return it back to this form here. And there's some reasons this is important. Both expanding and factoring are needed. That's why we learn both of them. Sometimes, you notice this is a multiplied form, right? You have 5 times a bracket. And this, once you expand it, you have an added or subtracted form, 5x plus 35. There's also, I know, some adding inside the bracket there, but the overall structure of this is 2 things being added, and the overall structure of this is 2 things being multiplied, 5 times a bracket. There's sometimes that you need this expanded, so you can, say, collect terms like we were doing in those other questions. There's other times it becomes very important to take this and turn it back into multiplication. I'm not going to get into details right now, but having that in a multiplied form turns out to be very advantageous for certain types of situations. So let's try and take those answers and figure out how we could have gone backwards back to the original question. Now, obviously, we already know what the answers are because we just did them, but let's try it. So 5x plus 35. Well, remember when we expanded the bracket, we multiplied 5 times x, 5 times 7. So what we're going to look now is we're going to try to go backwards. We're going to try to divide something out of those 2 terms. So we ask ourselves the question, what divides out of both 5x and 35? And the answer is a 5 comes out of both of them. The x is neither here nor there in this question because there's an x in one term but not the other. But both terms can be divided by 5. 5 can be divided by 5, and 35 can be divided by 5. So the way we often phrase this is we say we're going to pull out a 5. What we really mean, and I wish we said, is that we're going to divide out a 5. The 5 is going to come out front and divide out of everything else. So I would not recommend writing this out like I'm doing here, but I want, just so you can see what's happening, you want to be able to just do this in one step. And it's very easy to do once you get practiced at it, and it's fast, right? You don't want to go off to the side and do all this. But here's what's technically happening. We pulled out a 5, and so now it's multiplied out front. we're going to divide that 5 out of each of the other terms. So 5x divided by 5 is just x. And I put a plus sign in there because it may or may not be important, but we know, even if we don't need to write it, we know it's there. What's 35 divided by 5? That's 7. And again, I put the plus sign there. Now, when we go to pop those back in where we came from, that x doesn't need the plus sign in front of it, but that 7 does. We can't just write x7 because it's x plus 7, right? Technically, it's plus x plus 7. But so there you see that I managed to get back to my original question, 5 times x plus 7. How did I do it? I identified what divides out of both pieces and wrote that out front. And then I actually did divide that out of both pieces separately. Let's take a look at this second one. So this has now been factored. Common factoring. By the way, listen to the name common. You're looking for what is common to both terms or to every term. So c cubed minus 5c, you ask yourself, what is common to those? What divides out of both of those terms? Well, there's no number this time that divides out of both terms, but there is a c that divides out of both terms. So I write that c out front, the thing I can divide out of both terms, and then I ask myself, what do I get when I divide that c out? And again, don't write it like this. You want to get practice just taking this step directly. C cubed, divide out a c, you're left with c squared. Negative 5c, divide out a c, you're left with negative 5. So we have a plus c squared and a minus 5. I don't need the plus in front of the c squared, so I don't bother to write it, but I know it's there. And once again, you see, we have gotten back to the original question. I think I have so when we expand a bracket, we multiply the 5 into the bracket. When we go backwards and factor, we divided the 5 out of the bracket. Look at the x plus 7. It's 5x plus 35 with a 5 divided out of it. And the 5 comes out front. And you could re-expand that, and of course you get back to the same thing again. Same thing for this one. When we expand the bracket, we multiply the c into the bracket. When we factor, we divided the c out of the bracket. C cubed minus 5c, divide them both by c, and you get c squared minus 5. So you pull out what's common in front and divide everything that's left behind. So, summary so far. Factoring in general is trying to reverse the process of expanding brackets. That is the big picture. All types of factoring are trying to reverse the process of expanding brackets. Our first type of factoring, common factoring, we look for anything that is common that divides out of every term. And then we pull that in front of the bracket. Yes, we are going to learn, as I've been saying, a number of other types of factoring. This is really, really important. Always, always, always start by looking for common factors to pull out first. So when we learn the other types of factoring, sometimes there will also be common factoring, and you always look for that first before doing anything else. So always look for common factors first. So here we got some practice questions. I think I'm going to do the first one at least and maybe get you to try some of the others. We'll see what happens. 14x squared plus 63. So we are going to ask ourselves the question, what divides out of both 14x squared and 63? Well, there's no x's in this term, so no x's come out of both terms. Is there a number that goes into both 14 and 63? There is. Check your times table sheet. It's always the fastest way to do these still, even though you're allowed a calculator. That times table sheet is handy. A 7 divides out of both 14 and 63. So that 7 is what we are going to pull out front, like so. And I would write it like that. I would pull the 7 out front and write and show the bracket that you're going to then fill in. And now we are going to divide 7 out of both of these pieces, 14x squared divided by 7, that's going to be 2x squared. I'm actually going to do it down below. Again, I would not recommend rewriting this in separate, but just so you see what's happening, I'm going to divide the 7 that I pulled out front, I am going to divide out of 14x squared, and that leaves me with 2x squared. Positive, but I don't think I need to write it in this case. And I'm going to divide the 7 out of the positive 63. 63 divided by 7 is 9. Positive 9. That plus sign I do need to write, right? Both plus signs are there. There is a plus sign right here, but we don't need to show it. But this one absolutely needs to be shown. Again, I know I'm harping on this, but let your default be there's a plus sign there, and only drop it once you're sure you don't need it. There's our first one done. Okay, let's ask the same question. What divides out of both 10n to the 4 and 2n to the 7? Well, 10 and 2 can both be divided by 2. Jump the gun there. And n to the 4th and n to the 7, I can pull out, remember this means n times n times n times n, and this means n times n times n times n times n times n times n, 7 n's. I can pull out 4 of those n's, n to the power of 4, right? So I can pull out a 2 from both terms, and I can pull out 4. I can pull out all 4 n's here and 4 of the 7 n's there. So I can pull out 2n to the 4. That's what comes out front of the bracket, right? Figure out what comes out of everything and write it out front. Now, what remains behind when you divide? From the first term, 10 over 2 is 5, and n to the 4th over n to the 4th is just 1, so we don't need it there, so that's a plus 5. From the second term, negative 2n to the 7, what comes out? The 2's cancel, leaving just 1, and n to the 7 over n to the 4, subtract the exponents, is n to the 3, so we have negative n cubed, and that goes there. So there is our second answer. And I want you to notice here that if you're ever thinking like, oh, I'm not sure if I did that right, you can always just expand this bracket, your answer, and make sure it matches the original question. 2n to the 4th times 5 is 10n to the 4th. Oh, good, that's right. 2n to the 4th times negative n cubed, that's negative 2n to the 4 plus 3 is 7. Yes, it works, right? So factoring, one nice thing about factoring is it's easy to check your answers. You just expand the bracket. Okay, let's look at this last one. You can see I'm stepping up the difficulty here. And I say this a lot too, but remember, we're just overviewing these topics. I show you a couple easy ones, and then like a easy one, a medium one, and a hard one, right? Of course, you're going to be doing the practice in your textbook and going through all the different types with multiple practice questions on every type. What comes out of all 3 terms? What comes out of 9p cubed r squared and 15pr to the 5th and 3pr squared? Well, let's break this down. Let's look at the numbers first. 9, 15, and 3. What divides out of all of 9 and 15 and 3? What's the biggest thing? I think it's just going to be a 3 that comes out of all of those. P cubed, P and P. Well, we can only pull out a single P, right? Because all 3 terms have just one P. And if there was any term that didn't have any P's, you couldn't pull out the P's at all. Only if it's in all 3 terms. And what about the R's now? We have R squared, R to the 5th, and R squared, so we can pull out R squared. 2 of the R's can come out of the first and the last term, and the middle term, 2 out of the 5 R's can come out. So R squared divides out of every term. And then why don't you try finishing that off so that 3pr squared is going to go out front, the thing that you're pulling out, and try those 3 divisions to see what's left behind. Okay, so we recognize that 3pr squared can be divided out of every single term. So we pull that out, is the phrase you'll hear. We write it out front with a bracket behind it. And then to find out what's left behind, again, I'm going to write them down below, but I strongly recommend you get to the point where you don't have to. You just want to look at this and say 9 divided by 3, p cubed divided by p, and r squared divided by r squared. Or even beyond that, the way most people start to look at it, the 3 is the 3. 9, you divide out the 3, and there's 3 left. Often people will look at the variables like this. They'll say, I pulled a p out from p cubed. That means there's p squared left. I pulled an r squared out. Well, I pulled all the r's out, so there's no r's there. What about this second term? Negative 15, I pulled out a 3, so that's negative 5. Oh, I've already jumped the gun there. I pulled a p out, and so there's no p's left. Or if you look down it this way, p over p cancels out, right? R to the 5th over R2 is R cubed. So again, one way when you get kind of stuck is to actually do the division. The other way is to think of it like this. I pulled a p out, and there was only one p there, so there's nothing left. And I pulled out 2 r's, r squared, out of 5, so there's 3 r's left behind. So you see how you don't need to go and do all these divisions over here, but technically you are dividing. This last one's really important, as people will say 3pr squared, oh, I pulled everything out. Here's where it is really important to remember that you're technically dividing, because people will just not put anything there. But there is a 1 left behind, because you divided 3pr squared out of 3pr squared, leaves you with a 1, not a 0. And so there's some common factoring. And this is what I've been sort of saying all along, that as you get practiced at this, you don't go off to the side and do a bunch of divisions to see what's left behind. You imagine pulling pieces, you pull the piece out front, out, and you see what's quotation marks left behind after you divide that out. If you have a negative on the highest power of the variable, we don't like that. Math people don't like their highest term of the variable to be negative if they can help it at all. And for reasons that you won't discover until you're in the 07 level math courses, and when you'll see why this is actually really important, when the highest power of the variable is negative, we take that negative out with the common factor. So here you see we have an h to the 7, an h to the 4, and an h to the 3. The highest power of the variable, h to the 7, is a negative term. So when we common factor, that negative is going to come with it. So let's start by asking what we can take out. We have h to the 7, h to the 4, and h to the 3, so we can take out h cubed, right? Is the most h's we can take out of every term. What about the numbers? Whoops. Oh yeah, so the h cubed is going to be part of what I take out. How about the number that comes out of 12, 8, and 20? Well, 4 divides out of all 3 of those. But because the highest power is negative, we are going to pull out a negative 4. So there is what we're going to pull out of all 3 terms. Let you stare at that for a second, make sure it makes sense. I took as many h's as I could possibly take out of every term, and I took the highest number that goes into all 3 of the other numbers, and because my leading term, my highest power, is negative, I brought the negative on out front along with it. So now let's see what's left behind in each term. So negative 12, let's try this without showing the divisions on the side. Negative 12, we divided out a negative 4. So negative 12 divided by negative 4 is positive 3. H to the 7, we divided out h cubed, so we took 3 of the 7 h's away. We're left with 4 of them behind. Again, you see very quickly how you don't think about that as division. You just think, I pulled 3 out and there's 4 left, right? I pulled 3 out of the h's out of 7, so there's 4 of them left. But in the back of your mind, you remember what you technically just did is h to the 7 over h to the 3. And that becomes important when everything cancels out, as we saw with the +1 in the last example. Next one, 8. So we pulled this out. 8 divided by -4 is -2. H to the 4 divided by h to the 3, or I pulled 3 of the 4 h's out, 1 h is left behind. And the last term, I pulled a -4 out of -20, so divide. -20 divided by -4 is 5. And h cubed, I pulled all 3 h cubes out, so there's no h's left in the last term. And if you want, I thought I might have done this, but I don't. If you want, you can always re-expand this bracket. Let's do it fast. Make sure you get back to the original. -4 times 3 is -12. -4 times -2 is +8. -4 times +5 is -20. Okay, the numbers all check out. H cubed times h to the 4th is h to the 7. Good. H cubed times h is h to the 4th. Good. H cubed just times the 5 is just the h cubed, right? So you re-expand the bracket, you can check your answer. Okay, factoring type 2. This is just a little one. This does not come up very often in this course especially. It turns out to be useful in a very specific but important situation that comes up in future courses. But in terms of this course, it's just sort of a little side there, like, hey, let's show them factoring by grouping because they're going to need it in a later course. So how to spot when you might be doing factoring by grouping is when they give you a question with 4 terms. It might not be, but that is one of the key indicators that you might have a factoring by grouping question, because you need 4 terms to do it. So there's an example of one that works with factoring by grouping. Here is the process for factoring by grouping. We break them up into the first 2 and the second 2. And we common factor the type that we just did. We common factor the first 2, and we common factor the second 2. We do them separately. So I'm not going to look for something that comes out of all 4 terms. Although if there was something that came out of all 4, I would take it out, because remember, we always do common factoring first. But instead, there isn't anything, by the way. Take a look. There's nothing that comes out of all 4 terms. A P comes out of these 2, but not those 2. A Q comes out of the first and the third, but not the others. And there's no number. 2 comes out of 10, 8, and 80, but there's no 2 in this first term, right? So there's nothing that comes out of all 4 terms. So separate the first 2 and the second 2 and common factor them. What is common to PQ and -10p? Well, they both have a p in them. That's the only thing that's common. What's left behind? Divide a p out of PQ, and you have a Q. Divide a p out of -10p, or pull a p out, and you're just left with -10. What's common to the second 2? Well, they both divide by 8. No Q's over here, but they both divide by 8. So there's an 8 common, so I pull out an 8, and I divide to see what's left behind. 8Q divided by 8 is Q. -80 divided by 8 is -10. Okay, so I've common factored the first 2 and common factored the second 2, which normally would be a terrible idea, but when you have a factoring by grouping question, something magic happens. Look right there. The exact same thing was left behind from both of those factorings. Now, how often does this happen in the real world? Not very often. By real world, I mean if you were to make up random questions with 4 terms, very, very rarely would factoring by grouping work. But when it does work, it's a nifty little tool. So if you don't get matching brackets here, if these 2 brackets don't work, then back to the drawing board. Factoring by grouping will not work. In really nasty questions, sometimes you have to rearrange the terms and try again. I don't think they're going to do that to you in this course, but it is something that can happen. So you're looking for getting the exact same thing left behind, because now that purple bracket, listen to my words here, that purple bracket, the entire purple bracket, can be common factored out like that. And then you see what's left behind when you pull out a q minus 10 from both of the other pieces. What's left behind, you can see in black, is a p plus 8. So think of it this way. If this said, instead of a purple bracket, if you had p times t plus 8 times t, you could pull the t out. You could common factor it out. Same thing with an entire bracket. You can common factor out the entire bracket and write out what's left behind there. That is factoring by grouping. That's our answer there in the bottom line. So let's try another one. I'm going to start you off. So there we have, you say, oh, 4 terms. I wonder if this is a factoring by grouping question. Let's try. We're going to common factor the first 2 and common factor the second 2. What's common to both these terms, xy and 2y? Oh, they both have a y. That's it, right? So a y comes out of the first 2. What's common to these 2? They both divide by 3. So we are going to pull a 3 out, but here this is important. That negative sign right there has to come with it. So we are going to pull a negative 3 out, and that's what you're going to divide out of the others. Why don't you give this a try and see how far you get. Okay, factoring by grouping. We recognize 4 terms. We know it might be a factoring by grouping question. We common factor what's common to the first 2. So I pull out a y. What's left behind? Xy divided by y is just x. And 2y divided by y is just 2, but of course it's a plus 2. Don't forget the plus sign. And again, there's also a plus in front of the x, but we can get away without writing that one. Here we pulled out a negative 3. So negative 3x divided by negative 3. Well, you just took out the negative 3. That what's left behind is x. And negative 6 divided by negative 3, positive 2. Okay, and then we say, oh, look, goody, it's going to work because I got the exact same thing left behind in both. And again, if you get x plus 2 here and x minus 7 over here, stop, because factoring by grouping will not work on that setup. So we identify that both of those pieces have an x plus 2. We common factor out that entire bracket. We pull it out front. And you can see what's left behind is a y minus 3, just like that. Okay, so type 2, not that important, but you will get a few factoring by grouping questions. Not nearly as many as common factoring and the other 2 types that we still have to do, one today and one next class. One wonderful thing about factoring is you can always double check your answer, as we said, by re-expanding the bracket. So let's take that answer that we got, and we're going to expand that bracket. So this is going back to our expanding practice, which means we're going to take both of the things here, the x and the 2, and multiply them through the second bracket. So you can see I've done that there. I've taken the green x, multiplied it through the second bracket, and the orange plus 2, and multiplied it through the second bracket. X times y is xy. X times negative 3 is negative 3x. Positive 2 times y is plus 2y, and that plus sign is critical. You can't just say 2y. Positive 2 times negative 3 is negative 6. So there's my bracket expansion practice, and look at that. Sure enough, we get the same thing we started with. The order of the terms here is different, but that doesn't matter. We can reorganize them, right? The fact that this has a minus 3x plus 2y, and this has plus 2y minus 3x, that's the same thing. Both terms have the correct sign, the plus and the minus. Okay, so if you're ever unsure about a factoring question, expand your answer, and make sure you get back to the original question. Factoring type 3, this will be a quick one, difference of squares. And so that is, remember those words from our first lesson, that is just reversing one of the special products that we discovered, those little patterns we saw repeating themselves. So remember when we expanded a minus b times a plus b, the middle terms always canceled out and we got a squared minus b squared. So to reverse that, all you got to do is recognize that you have an a squared minus b squared pattern, and you know it will turn into this when you write it as, when you reverse the bracket expansion, which is factoring. So this first one, you say, oh, x squared minus y squared, right? I know that that must have come from x minus y times x plus y, because of that special pattern that we noticed, the difference of squares pattern. If you expand this answer, the middle terms cancel out and you just get x squared minus y squared. How about this one? B squared minus, 36. Is that something squared? Yeah, it is. B squared minus 6 squared. So that fits the pattern. Something squared minus something squared. A squared minus B squared, right? So as soon as you recognize you have the pattern b squared minus 6 squared, you know that must have come from b minus 6 times b plus 6. How about this one over here? You can see I'm making you think a little more. Does this fit the a squared minus b squared pattern? Is t to the power of 6 a perfect square? Well, yeah, because remember, t cubed times itself gives you t to the power of 6, not t to the power of 9. T cubed squared, you multiply the 3 times 2, is t to the 6. How about 1? Is 1 a perfect square? Sure it is, because 1 times 1 is 1 squared. So this actually fits the pattern. As soon as you recognize that it fits the a squared minus b squared pattern, you can factor it a minus ba plus b. So t cubed minus 1, t cubed plus 1. You can reverse the order of the brackets too, right? Because it's just multiplication. So you could say x plus y times x minus y, same thing. Okay, so there's your difference of squares factoring. You just recognize the a squared minus b squared factoring. You remember the pattern, the special pattern that we had, and I would definitely be writing this on your cheat sheet, that a squared minus b squared factors as a minus ba plus b. So this is really important. A difference of squares, like these ones, factors a square minus another square. A sum of squares does not factor. You cannot factor x squared plus y squared or b squared plus 36. They cannot be factored. Now you might be thinking, well, isn't it just going to be x plus y times x plus y? And if you try that expansion, you'll see right away that that does not work, because you get x squared plus xy plus xy plus y. The middle terms do not cancel out. You get all these extra terms there. So there is no way to factor a sum of squares, two squares being added together. If you get that question, you say does not factor, or I think some courses have you call those prime when they can't factor. So if none of the factoring methods work, then you say that that expression is prime, doesn't factor. We do with the difference of squares here. I'm going to remind you what we said in our first little bit, common factoring, that you always common factor first. So before you do anything else, look for common factors. So on this one, I notice that 18m squared minus 32, what's common to both those? A 2 can divide out of both those. So pull that 2 out. What's left behind? 18m squared divided by 2. 18 divided by 2 is 9. Negative 32 divided by 2 is negative 16. So there's some more common factoring. And now look what I've done. Wait a minute. 9m squared is a perfect square because 3m times itself, right? 16 is a perfect square because 4 times itself. So once you common factor, you actually have our a squared minus b squared pattern. So the 2 stays there, the 2 doesn't go away, but now factor everything that's left behind like that. Now we're going through lots of material. This is an overview, so you want to be pausing, I think, if you're watching this video later or if you're going back to review. You're not going to watch me breeze through a few examples of everything and instantly know how to do it. You need to do the practice. But what the key here is you common factor. You look for common factors first and then any of the other types of factoring that we do. Why don't you try that one? Look for common fact. Even if you're not sure about the different squares, just start by looking for common factors. Okay, so we always check for common factors first. What divides out of both of these? Well, in terms of the numbers, I see that a 6 comes out of both 6 and 24. In terms of the letters, I got t to the 13th, and then over here a single t. Well, that single t can divide out of both. So I can pull out 6t from both terms, and then I divide to see what's left behind. 6t to the 13th over 6t. The 6's cancel. I'm just left with t to the 12th. T to the 13th over t, or I pull 1t out of the 13 t's, and 12 are left. Negative 24t divided by 6t, well, the t's cancel, and negative 24 over 6 is negative 4. So there is my common factoring, which I always look for first. And now I double check in case I can carry on with another type of factoring, and I can, because these two both are once again perfect squares. So I again have a squared minus b squared pattern. No, I don't do it. So the square root of t to the 12th is t to the 6th, because t to the 6th times itself equals t to the 12th. And the square root of 4 is 2, because 2 times 2 is 4. So the difference of squares pattern, a squared minus b squared becomes a minus b times a plus b. And that's our answer. So again, the key takeaway from this last little section was check for common factors first, and then check to see if there's any other type of factoring that can still happen.